For our next division situation, we're going to consider a polynomial divided by a monomial. An example of this would be 15x cubed minus 5x squared plus x plus 5, all divided by 5x. Because we have an entire polynomial divided by an individual monomial, that monomial can be thought of as a divisor to each one of the terms in the numerator. So 5x is going to divide into 15x cubed, into 5x squared, into x, and into 5. And we'll simplify each one of those terms individually with the 5x as their divisor. So 15x cubed over 5x minus 5x squared over 5x plus x over 5x plus 5 over 5x. And considering each one of those simplifications individually, our first one leaves us with 3x squared. Our second one just leaves us with an x. Our third one leaves us with a 1/5. And the last one leaves us with a 1 over x. And the division of this polynomial by that monomial is that result, each term thought of individually. Let's look at another one of the same type. 8x to the 4th y to the 5th minus 10x to the 4th y to the 3rd plus 12x to the 2nd y to the 3rd, all of that over 4x cubed y squared. Again, we have a 3-term polynomial with a 1-term monomial divisor, and we'll think of each one of the divisions individually. 8x to the 4th y to the 5th over 4x cubed y squared minus 10x to the 4th y to the 3rd, 4x cubed y squared plus 12x squared y to the 3rd over 4x to the 3rd y squared. This one's a little bit tougher because we have two different variables that we have to manage, making sure we're subtracting for both of them. We probably will end up with some terms in a denominator, and that's okay. There might be an individual fraction part to the answer, similar to what we had here with the 1/5 and the 1 over x. So our first division, 8 divided by 4 is 2. We have 1x and 3 y's, subtracting the powers again, thinking back to our exponent rules from Algebra 1. 10 does not divide by 4, but we can simplify it to 5 over 2. We're left with 1x and 1y, subtracting both of those powers. And for the last term, we have a 3 from the 12 divided by the 4. We have one more x in the in the denominator than in the numerator, but we have one extra y in the numerator, and we end up with 3y over x. So here we have our simplified version of that polynomial divided by monomial. Again, 3 terms in the numerator means we're going to have 3 different divisions. 4 terms in the numerator means we need 4 different divisions.